Our next talk is from Dirk Lauinger from the Sloan School of Management, and it's called Vehicle to Grid, Mobile Energy Storage from Electric Vehicles.
We have to transition to a low-carbon society. This means that we need to store massive amounts of wind and solar electricity. One option is to put up battery containers, like this one on the slide. That's very expensive and takes up quite a bit of space. However, there is an alternative: electric cars. We need them anyway to clean up transportation, but they also store energy. In fact, 10 electric cars store the same amount of energy as one battery container. Yet, how can electric cars provide energy storage, say to power your home, when they are supposed to be driving you around? But actually, even during peak rush hour, over 90% of all cars are parked. If many of those parked cars are electric, that's a vast amount of unused storage capacity. Using some of that storage for the electricity grid would avoid having to pay for batteries twice, once for the grid and once for the cars. To make this work, we need special charging stations that allow the cars to discharge power back into the grid. This idea is called Vehicle to Grid and is the focus of my research. We've had these charging stations for 20 years already. They work fine. But in order to use them, we need to figure out how to charge and discharge the batteries so that all cars collectively meet society's storage needs as well as possible, while making sure that people can still drive their cars pretty much whenever they want to. The issue is that we don't know in advance how people will use their cars or how much storage the grid will need. In my research, I rely on past data to build scenarios of how people might use their cars and of how much storage the grid might need, and then I use these scenarios to build an optimization problem that coordinates the use of all cars for both transportation and storage. Solving this optimization problem directly is difficult because of the many cars it needs to coordinate and the many scenarios it needs to work for. Luckily, there's a mathematical theory called duality theory that I have been extending to formulate an alternative version of the problem that gives the same solution as the original, but is much easier to solve. My research says how to operate cars to provide both electricity storage and transportation. And it can be used to estimate the cost savings of replacing battery containers by vehicle to grid. Ultimately, some of these cost savings should find their way into the pockets of electric vehicle owners, which will make it more attractive to switch to electric vehicles, if you're considering that. The math that I developed can also be used to control other decentralized resources, heat pumps, for example. All of this should help us speed up the transition to a low-carbon society.